NASA's James Webb Space Telescope has hardly opened its eyes, and the universe is new, more mysterious, more beautiful than humanity's dreams.
For years, astronomers have suspected that the early universe was far more active, complex, and structured than our current models allow. But suspicions are one thing. Proof is another. And now, the James Webb Space Telescope has delivered that proof. In the depths of cosmic history, Webb has found a galaxy so ancient, so luminous, and so chemically rich that it rewrites the rules of galaxy formation and perhaps even the story of the universe itself. This is not just about a single object in space. It's about what it represents. Evidence that the universe's first billion years may have been a frenzy of creation, complexity, and order far beyond anything we imagined. And as Webb's instruments keep pushing deeper into the dark, one thing has become clear. What we've always suspected about deep space may have been true all along. Back in 2022, the most distant galaxy ever seen was GNZ 11, discovered by Hubble. It was a milestone, an object so far away that its light had traveled over 13 billion years to reach us. But then came James Webb with its massive 6.5 mirror and infrared vision designed to detect the stretched-out light of the earliest galaxies. Almost immediately, Webb shattered Hubble's record, spotting a galaxy called JADESGZ10 with a redshift of 14.32. That meant Webb was looking at a time just 280 million years after the Big Bang. And then Webb found something even stranger, MOMS 4, with an even higher redshift of 14.44. On paper, this was already astonishing. But the real shock came when astronomers looked closer. MOMS Z14 was small, just 500 light-years across, but blindingly bright. A compact furnace of newborn stars burning at an intensity no galaxy from that era was supposed to achieve. Our models had always assumed that such ancient galaxies would be faint, slow to form, and chemically simple. MOMS Z14 was none of those things. When Webb spectrograph analyzed MOMS Z14's light, it revealed something no one expected. An unusually high abundance of nitrogen. This chemical fingerprint matches the signature of ancient star clusters orbiting the Milky Way today, suggesting that multiple generations of stars had already lived and died before MOZ14 was even formed. This was a revelation. It meant that galaxy evolution in the early universe started far earlier than anyone thought possible. To see nitrogen at these levels meant that supernova explosions responsible for seeding space with heavy elements had already been happening for hundreds of millions of years. That pushes the timeline for stellar birth and death cycles into an era we once believed was nothing but chaos and gas clouds. It was as if Webb had caught a glimpse of a much older hidden chapter of cosmic history, one that left its imprint in the chemistry of a galaxy shining from the edge of time. The surprises didn't stop there. Galaxies with such intense star formation almost always have a supermassive black hole at their core. These central giants help regulate star birth, influence galactic structure, and shape the evolution of their host galaxies. But MMZ14 had no such core. Webb detected no signs of a black hole in its center. No intense radiation, no gravitational signature, nothing. It was as if the galaxy's stellar engine was running at full capacity without the central mechanism we thought was essential. This challenges one of the most widely accepted ideas in astrophysics that black holes and galaxies grow together, each fueling the other's evolution. If MMZZ14 can exist without a central black hole, then maybe black holes are not as critical to early galaxy growth as we believed. Or maybe this galaxy was caught in a rare transitional phase, a fleeting moment before a black hole was born in its heart. Before Webb, galaxies like MOMS Z14 were considered extremely rare, statistical outliers in a mostly quiet early universe. But now they are turning up more often than expected. These bright red points are appearing in Webb's deep field images with increasing frequency, and each one undermines another assumption. If galaxies this small could form stars this quickly and enrich themselves with heavy elements this early, then the universe's first billion years must have been far more dynamic than our cosmology textbooks describe. This doesn't just tweak the margins of our models. It forces us to reconsider their foundations. Our simulations of early galaxy growth will need to account for higher rates of star formation, faster chemical enrichment, and possibly entire phases of evolution we've never modeled. And if galaxies like MOMS Z14 are just the beginning, then Webb may be about to flood us with discoveries that confirm what astronomers have quietly suspected for years, that the young universe was a far more sophisticated place than we dared to believe. As Webb's surveys expanded, MOMS 14 stopped looking like an outlier and started looking like part of a pattern. Dozens of similarly ancient, compact, and luminous galaxies began to appear in the data, each one pushing the timeline of cosmic evolution back further than our models allowed. Some were even richer in heavy elements than MOMS 14, hinting at an even longer history of stellar birth and death cycles before the era we've been taught to call the beginning. This wasn't supposed to happen. In the Standard Model, the early universe was dominated by chaotic clouds of hydrogen and helium gradually coalescing into the first stars. The reality Webb is showing us is something else entirely. A universe that wasted no time in building complexity, one that may have been structured and active almost from the start. The suspicion astronomers have carried for years that the cosmic dawn was not a slow, simple process now has hard evidence scattered across Webb's deepest images. Adding to the intrigue, a separate study has revealed something that ties disturbingly well into Webb's findings. Most galaxies seem to rotate in the same direction. This is not what we expect in a random isotropic universe where spins should be split roughly evenly between clockwise and counterclockwise. The discovery hints at a large-scale coherence, an underlying order to cosmic structures that challenges the principle that the universe has no preferred direction. Could these early galaxies, rich in metals and forming stars at unprecedented rates, be part of a grander, more ordered cosmic architecture? If so, then the suspicion isn't just that the early universe was more active. It's that it may have been shaped by conditions or forces that still leave their fingerprints today. The anomalies don't stop with star formation and galactic spins. Some scientists interpreting the mounting evidence are now revisiting a bold idea that our entire universe could exist inside a black hole. In this framework, the Big Bang wasn't the start of everything. It was the bounce or rebirth that occurs when matter collapses beyond a critical point in another larger universe. If true, this could explain why the constants of physics seem perfectly tuned for the existence of galaxies, stars, and life. It could also account for the surprising level of organization we're detecting in the earliest structures. In such a model, every black hole could be a gateway to a new universe, each with its own physical laws. And only those universes stable enough to evolve survive. For decades, this was the stuff of fringe speculation. But Webb's discoveries are giving it new life. Perhaps the most thought-provoking interpretation of Webb's data is also the most unsettling. Some researchers are beginning to entertain the possibility that the universe isn't just evolving. It's aware of its own evolution. The intricate order in galactic rotations, the rapid chemical enrichment, the improbable symmetry in structures. These could be signs not of randomness but of a system that is self-organizing on the largest possible scale. In this view, every star, every galaxy, every sentient being could be part of a cosmic feedback loop. The universe observing itself, adjusting, and growing in complexity over time. If that's the case, then Webb's discoveries aren't just rewriting the history of the cosmos. They're hinting at a deeper truth we've always suspected. That the universe is not indifferent but participatory, and that we are not separate from its purpose but embedded within it. For decades, astronomers have whispered that the early universe might not match the quiet, simple picture painted by our models. Now, the James Webb Space Telescope has confirmed those whispers and turned them into undeniable evidence. Galaxies forming impossibly fast, spinning in coordinated ways, enriched with heavy elements long before they should exist. Patterns in cosmic structure that suggest an underlying order. The possibility that our universe is the interior of a black hole born from another reality. And perhaps most provocative of all, the hint that the universe itself is a self-organizing system, aware in some way of its own unfolding. These aren't isolated curiosities. They are connected threads in a much larger story, one that challenges the foundation of cosmology. If the early universe was richer, faster, and more structured than we thought, then the origins of galaxies, stars, and even life may be tied to forces or intelligences that transcend our current understanding. Webb hasn't just expanded our view of space. It's cracked open the door to questions we've been too cautious to ask. The evidence is there. The suspicions were right. The only question now is, are we ready to follow this truth wherever it leads? Let us know what you think in the comments. Could these discoveries be signs of a designed evolving cosmos? Or are we still underestimating the raw chaotic power of nature? If you found this as mind-shattering as we did, hit like, subscribe for more deep space revelations. And share this video with someone who still believes the universe is just random dust and darkness. Because out here in the oldest light of the cosmos, the truth is finally coming into focus. And it's more extraordinary than we ever dared to imagine.